This video is the first in a series of videos on Level 1 Algebra for the SAT Math. There are 3 levels of difficulty. Level 1 is the most basic, so this can be considered an introductory level to SAT Math Algebra questions. I recommend that as each question is presented on the screen, pause the video, read the problem, try to solve it on your own, and then unpause the video to see if you solved it correctly. And if you don't know how to solve it, then of course watch the video solution to develop strategies for solving these kinds of questions. So we begin with the first problem. Again, you need to pause the video and read it to yourself. I won't read these problems out loud. But ultimately, we have to select a system of linear equations that represents this situation. So in this problem, we have shirts and pants, and we know that X is representing the price of each shirt. So we know that shirts have to be associated with X. Let's take a look at Hero's purchases, and he purchased 4 shirts. And he did so and spent a total of $86. So we already know that we can develop an equation that says the number of shirts that he purchased multiplied by the price of each shirt. So we need a 4x in each equation. Ultimately, he spent $86, so that's going to be equal to 86. But he didn't just buy shirts. He also bought pants. And y represents the price of each pair of pants. Hero bought 2 pairs of pants. So we would add the number of pairs of pants he purchased to multiply by the price of each pair of pants. So that would be plus 2y. So we need to select an option that has the equation 4x plus 2y equals 86. Now, truthfully, there's only one choice that has that equation. It's this one right here. So this must turn out to be the correct answer. I would recommend pausing the video and seeing if you can develop a similar equation based on what Sophia purchased. We can then go back and confirm that the equation holds true. So let's quickly look at what Sophia purchased. She purchased 3 shirts. So for Sophia, it's going to be 3 shirts multiplied by the price per shirt. She also bought 5 pairs of pants, so it would be plus the 5 pairs of pants multiplied by the price per pair of pants, and that has to equal 166 because that's what she spent in total. Lo and behold, if you look at the second equation in choice A, it does also match. So choice A is the correct answer to this first problem. Let's move on to number 2 in this set. Again, pause the video, read the problem to yourself. One of the keys of some of these algebra questions is watching out for the phrase constant rate. Whenever you see some quantity changing at a constant rate, that means that it's a linear type of problem. So it might be an increase in a linear situation. It might look like that, or it also could be a decrease. Theoretically, it might look like this, but then of course it wouldn't be a changing quantity, so that's probably ruled out. But the bottom line is, on the SAT algebra, if you see the phrase constant rate, you have to think of linear situations. Now, when you learned about linear situations in your algebra class, you probably learned about the following equation. It's known as the slope-intercept form of a line. It's y equals mx plus b. Now, a lot of times we can eliminate choices by looking at the slope, because the slope is the rate. It's how quickly something is changing. And if we go back and read this problem, we could probably fish out what the slope is. It says that the roller coaster car is rising at a rate of 8 feet per second. So every second, the roller coaster car is increasing its height by 8 feet. That's a slope. So we already know that we can fill in 8 for our slope. Our equation becomes y equals 8x plus b. So again, a key point is that when you see a quantity changing, then that's going to be the slope. In this case, 8 feet per second is the slope. Now, they're not actually using x in this situation. We can see that instead of x, the variable that they're using is s. So we can make a quick modification to our problem. So we know the correct answer has to have an 8 times s. We can see choices A and C both contain that. So you can eliminate B and D. And then often what you want to do on the SAT is just look at the difference between the remaining choices. And the difference is that in choice A, we have a y-intercept of 15, and then in choice C, we have a y-intercept of 335/15. Not really sure where the 335 would come from. If you reread the problem, you would notice there's really no mention of the 335. There is a mention of the height, 15 feet. And that's where the roller coaster starts. If you think of a graph of this scenario, you might imagine that the roller coaster begins at a height of 15. That would be the y-intercept. And then based on the positive slope of 8, it would rise 8 feet every second. So it would look something like this. So lo and behold, the y-intercept will be 15. We can fill that in for the y-intercept, and that leaves us with choice A as the correct answer. We'll move on to number 3. Now, in this case, we are given the graph of 2 lines. You can see there's one line that slopes upward, and there's another line that slopes kind of horizontally. In fact, the slope is 0 of that line. And this question asks us for the solution to this system. Now, again, this is level 1, so it's pretty basic. If you ever need to look for the solution to a system of equations, and they give you the graph, then you're in good shape, because the solution is simply the point of intersection. So you just want to look at the graph and find out where these 2 lines intersect. That's going to be the solution. So we can see that they intersect at this point right here. The x-coordinate of that point appears to be 2, and the y-coordinate of that point appears to be 3. So the correct answer must be 2, 3, and lo and behold, that is choice C. Moving on to the next problem here. We have ourselves a function. We see f of x is equal to 2x minus 1, all divided by 3. This is basic function review. We have f of 5, so we know that the 5 inside the parentheses is the x value. So we're going to rewrite the function, but we're going to replace each x with the number 5. So it would look like the following. When I plug in a number for x, I do generally like to plug it in using parentheses. So if you see me do that, I would recommend that you do the same. And now it's really just a matter of simplifying the right-hand side of this equation. So 2 times 5 is 10. 10 minus 1 is 9. So we're left with 9 in the numerator divided by 3. But of course, if we divide 9 by 3, we would get 3. So this means that f of 5 is going to equal 3. The problem wanted the value of f of 5, so the correct answer is choice C. By the way, important note about this type of function notation. Remember that the number inside the parentheses is your x value, and the number on the other side of the equals is the y value. Some students find that a little bit tricky. So you could think of this as the point 5, 3. So just a helpful tip there. We're going to move on to the next problem, a lovely little word problem. If you look at the choices, you're going to discover that this word problem is actually not an equation, but rather an inequality, because we have these greater than or equal to as well as less than or equal to symbols. So that's the first thing you might want to notice. And one of the phrases that show up in inequality word problems is the phrase at least. And we see that phrase right here when they said that the containers together have at least 400 red beads. Now, I have a very helpful tip here. Whenever you see the word at least, please do not think that that means less than or equal to. A lot of students think at least means less than or equal to. They are not the same thing. And in fact, it's the other way around. When you see the phrase at least, it actually means greater than or equal to. So if I have at least $10 in my wallet, I might have $10, but I might also have 11 or 12 or 20. So I have greater than or equal to $10 when I say at least $10. So you're looking for something that has the symbol greater than or equal to. Now, if you need a review of that, greater than or equal to would look like that. So if we're saying greater than or equal to 400, this is what we would be looking for in our inequality. Now, we can see choice A contains that as well as choice D, but B and C are going to be ruled out. So we're focused on these 2 choices because they have the proper inequality. But now we look back at the problem and we're given percentages. We say that the first container is 30% of the beads are red, and then in the second container we have 70% of the beads are red. Now in word problems, when you're translating percentages into the inequality, you want to make sure you express them as decimals. So recall that if you have 30%, then when you write that in an inequality, you have to take the 30% and you have to divide by 100. Now you can do that in a calculator, or you can remember that that basically means taking a decimal point and moving it 2 places to the left. So if you did that, you would get 0.30. So we need to make sure we pick the inequality with 0.30. 0.30, of course, is the same thing as 0.3. So if you look at the remaining choices, we have 0.3 right there. So D was wrong because it failed to convert the percentage into a decimal. We'll move on to the next problem. And we have a linear equation. Ultimately, in the problem, we are told that there are 3 small boxes that are being shipped. And if we look back at the given information, we can see that A, right there, A is the number of small boxes. So if they tell you that there are 3 small boxes, then you know that A must equal 3. So you guessed it, we're going to be plugging 3 in for A into this equation. And now some basic algebra will multiply 3 by 3 to make 9. And if we want to continue solving for B, we would have to subtract 9 from both sides of the equation. 9 minus 9 gives us 0. Now we have 4b is equal to 16. And then, of course, we have to divide both sides by 4. We'll swing over here, and we can see that b is going to equal 16. Now, don't forget what b represented. B was the number of large boxes. And that's exactly what this question is asking for, the number of large boxes. So the correct answer must be choice D. Coming along here to the next question, another word problem, another sort of system of equations. Again, pause the video and read the problem to yourself first. You would want to first focus on what the variables stand for. So we can see that S is the number of standard tickets, and then P is the number of premium tickets. So you have 2 kinds of tickets. S is standard, P is premium. Let's kind of focus on the tickets right now. Forget the costs. You want to take sort of one thing at a time. And in terms of the tickets, we know that they sold a total of 250 tickets. So we take the number of standard tickets, we add that to the number of premium tickets, and that has to equal 250. Now, we can see that equation is present in choices A and B, but it's not present in choices C and D. So let's get rid of those too. Now, the only difference between A and B is the 5S 12P versus 12S and 5P. So we just want to figure out whether the 5 should be associated with S or whether the 5 should be associated with the P. That'll help us decide between those remaining choices. Well, the 5 is a cost, and that's the cost of the standard ticket. So standard tickets would be S, and therefore the 5 has to be associated with the S. We can see that is true in equation A. It is not true in equation B, so let's get rid of B. A must turn out to be the correct answer. We'll move on to the next problem here, another little word problem. And this one's rather interesting because it's asking us to interpret the meaning of the number 75. Now, if you look at this equation, it's a pretty simple looking equation. It's x plus y is equal to 75. What I often tell students, if they're a little bit tripped up on a question like this, is to think of the dimensions of each term in the problem. And I'd like to explain what I mean by the dimensions of each term. We start out with this term x, and we can see that x is a number of minutes. So in particular, it's the number of minutes that she spends running each day, but the bottom line is its minutes. And then similarly, the y also represents a number of minutes. So on the left side, you are adding minutes plus minutes. But then ask yourself, if you add minutes to minutes, what would the outcome of that addition be? And of course, the outcome would be minutes. Minutes plus minutes must equal minutes. That might sound kind of obvious, but believe it or not, that can be helpful to think of the dimensions. So the correct answer has to be minutes. And we can see that every single one of these choices says minutes. It says minutes throughout. So that might not necessarily be helpful in this case, but it's something that I want you to keep in mind. Now, in the beginning here, x was the minutes spent running, and then the y was the minutes spent biking. Well, if you bike for y minutes and you run for x minutes, then you add those together, that would be the total amount of time that you spent sort of exercising. So that seems to be choice C. We can see choice C says it's the total number of minutes that she spent running and biking. D was close. You can see how the College Board likes to trip people up, but D says the number of minutes spent biking for each minute spent running. Well, no, that's not what we said. We said it's simply the total number of minutes that she spent exercising. So that would be the number of minutes running and biking each day. So C is the correct answer. We're going to move on to the next question here. This is very similar to a few questions ago where we did a function question. In this case, we're going to be replacing the x with 0. So we'll do this by plugging 0 in for x. Again, use parentheses when you do that. On the right-hand side, we have basically a -1 multiplied by 0, but any number multiplied by 0 is 0. So we have 0 plus 8, and of course that simplifies to just 8. So that would be the correct answer for that problem. We'll move on to number 10 here. A lot of information seemingly given here, but we're really just trying to interpret the meaning of the 24 and the 73. And we can see that the 24 corresponds to x and the 73 corresponds to the y. So all we really need to do is figure out what x and y stand for, and they're given to us in the problem. It says x is the number of triangles constructed. So if the x is 24, then we must have constructed 24 triangles. And then similarly, y is the number of rectangles constructed. But if y is 73, then there must have been 73 rectangles constructed. So choice A perfectly matches the given information in the problem. That is indeed the correct answer. We'll move on to number 11. We're given a simple linear equation, and then ultimately we are asked how many pieces did the pianist practice if the session lasted 30 minutes. So your task would be to figure out if the 30 minutes corresponds to x or corresponds to y. And we can see, if we read this very carefully, that the practice session lasted 30 minutes. So this simply means that the x value is going to be 30 because x is the number of minutes in the practice session. So we're going to plug 30 in for x. The good news is you can use a calculator throughout the duration of the math portion of the SAT. And if you work this out, you're going to get 3 for the y value. And for those who are interested, of course, the y is the different pieces of music that a certain pianist practiced. So the number of pieces of music she practiced was 3. The 30 minutes was how long her practice session lasted. So B would be the correct answer for that problem. This one's kind of interesting. Again, pause it and read it over. We have trays of cookies, but what's sort of tricky is that each tray can contain at least 50 cookies, but no more than 60 cookies. So oftentimes in that type of problem where it's kind of open-ended, you want to kind of examine the extreme case. Let me explain what I mean by the extreme case. Let's look at the fewest number of cookies first. Now that would mean we'd want to use the fewest number of cookies on the tray, so that would be 50 cookies per tray. We have 4 trays, so put that together, you've got 4 trays and they're each 50 cookies. So if you take the number of trays and multiply by the number of cookies per tray, you would get 200 cookies. That would be the fewest number of cookies that the bakery would have. But now we want to look at the other extreme and look at the largest number of cookies. So the largest number would be taking the 4 trays of cookies and this time multiplying it by 60 because the trays could hold up to 60 cookies each. And if we do that, we get 240 cookies. So somewhere between 200 and 240 cookies is what the bakery is selling here. We just have to pick a number that kind of fits in that range. And of course, the only number that fits in that range is 205. So in a problem like that, you kind of have to test the extreme limits, the fewest number, and then also look at the largest number. And then in this case, we just pick the one that's between those two. So we'll move to the next problem. We have another graph of a linear equation. In this case, the question says, what is the cost for each additional mile traveled in dollars of a cab ride? So let's look at the graph a little bit more carefully. Perhaps we can zoom in on it. We can select 2 key points. That would help us understand this. So let's look at this point right here. That's a nice lattice point. If we look at that point, we can see that the x value is just 1, and that's going to correspond to 1 mile. So we know that 1 mile is going to cost $5. So that's interesting. But in order to answer the problem, we need to look at the cost for another scenario. Now, look at the very next lattice point, which is right there. That lattice point seems to have an x value of 2. So we can see that 2 miles is going to have a certain cost. If we look at the cost, it's right there. Each unit on the y-axis is equivalent to 1. It just goes 5, 6, 7, 8, 9, 10. We can see, therefore, that that cost is $7. So now let's zoom out and look at the problem again. It says, what is the cost for each additional mile traveled? Well, 1 mile was $5, 2 miles was $7. You can hopefully see that as you travel an additional 1 mile, the cost went up by $2. So we increased the number of miles by 1, and then we increased the cost by 2. So it's $2 for that additional mile. That must be the correct answer, choice A. And that will conclude the first 13 problems of Level 1 Algebra. Please look for the next video in this series. That's going to be the next 13 problems. There are a total of 65 Level 1 Algebra problems that are published on the College Board's website. So ultimately, you'll see 65 of these. I hope you found this video helpful. And again, look for the next one in this series, which will help you prepare for the algebra portion of the SAT Math.